In 2011, a decision reshaped the landscape of space exploration. The US government, citing political and security concerns, imposed strict limitations on NASA's collaboration with China. The result? China was sidelined from the biggest stage of the time, the International Space Station. But for China, this wasn't the end. It was the beginning of a new chapter in space history. Instead of being left behind, China set out to build its own space station. And in 2022, Tiangong, a fully Chinese-made space station, launched into orbit. Since then, 4 crewed missions have successfully docked at Tiangong. It has become a symbol of China's growing ambition and capability in space. A country once dismissed as a rookie is now making giant strides to cement its place in the cosmos. And this? This is just the tip of the iceberg. Let's rewind for a moment. Remember Chang'e 3, Chang'e 4, and Chang'e 5. These weren't just exploratory missions. They were declarations of China's intent to dominate space exploration. In May of last year, China's Chang'e 6 rover made history. It landed on the far side of the moon, an uncharted territory, untouched by any nation. What's more remarkable, it returned to Earth with valuable lunar samples, completing a feat that astounded the world. This achievement solidified China's position as the first country to collect samples from the moon's far side. But China's ambitions? They stretch far beyond this. The nation is now training astronauts for an even greater mission, to land humans on the moon, and they're not rushing. China is laying the groundwork for a project of historic proportions, the International Lunar Research Station. This ambitious initiative isn't just about building a basic outpost at the moon's south pole in the early 2030s. China envisions a comprehensive lunar ecosystem, an expanded base, orbital stations, strategic hubs across the moon. The long-term goal? Human habitation and sustainable operations on the lunar surface. With these accomplishments, China is proving it's not just ambitious, it's serious about establishing a human-managed outpost on the moon. But the moon is incredibly harsh. How could humans possibly build a base there? How could astronauts stay for extended periods? 15 years ago, Japan's Kaguya spacecraft made a startling discovery. This wasn't just another meteor crater. It was something stranger. A deep pit, or perhaps the entrance to a cave. Since then, with help from India's Chandrayaan spacecraft and China's Chang'e orbiter, over 200 pits, resembling skylights, ranging from 5 to 300 meters wide have been identified. This sparked immense curiosity and excitement among scientists and the public alike. Could these be gateways deep into the moon? What role might they play in humanity's plan to conquer and build a base there? The moon, a merciless world where every condition opposes human life. Without a magnetic field, the moon is exposed to deadly radiation, 200 times higher than on Earth. Prolonged exposure to this radiation exceeds the safe limits for astronauts. Without an atmosphere, it is entirely vulnerable to deadly solar coronal mass ejections and a constant bombardment of meteoroids. Temperatures on the surface swing to extremes, 260 degrees Fahrenheit during the day and minus 280 degrees Fahrenheit at night. Such conditions put enormous stress on engineering materials. And then there's lunar dust. It's not just sharp, it clings stubbornly, accumulates on surfaces, and charges with static electricity. This makes it a serious hazard to both humans and machines. To survive and work there long-term would require overcoming immense, life-threatening challenges. But what if there were a way to escape these dangers? That's where these pits come into play. But what exactly are these pits? Why do they exist? After the initial Apollo missions to the moon, an astonishing discovery was unveiled. The dark plains, known as Maria, were actually ancient basaltic lava flows. What's truly fascinating is that this type of rock has a chemical composition remarkably similar to basalt on Earth, sparking an intriguing hypothesis. Could the moon have undergone geological processes similar to those of our planet? Billions of years ago, the moon wasn't the cold, quiet world we see today. Instead, it was a geologically active and dynamic place. Volcanic eruptions reshaped its surface with fiery rivers of lava, spreading across the landscape like glowing, molten streams. As these lava flows spread across the surface, they began to cool. The outermost layer, exposed to the frigid void of space, hardened quickly, forming a solid crust. But beneath that hardened shell, molten lava continued to flow, pulsing like a hot lifeblood within the moon's interior. Over time, as volcanic activity ceased and the lava drained away, these fiery rivers left behind massive underground channels, now hollow tunnels of enormous scale. Scientists call them lava tubes. On Earth, these unique lava tubes can be found in places like Hawaii or Iceland, with some tubes measuring dozens of feet wide, large enough for you to easily walk through. The most impressive example is in Hawaii, home to the longest lava tube on Earth. Kazumura Cave, stretching over 65 kilometers, is not just a geological marvel, but a gateway to the deep history of our planet. But, unlike Earth, the lava tubes on the moon might truly surprise you. Scientists have analyzed that the viscosity of lunar lava flows is at least 1 order of magnitude lower than Earth's lava. Combined with the moon's weaker gravity, just 1/6 of Earth's, this means that lunar lava flowed at nearly twice the speed of Earth's lava flows. As a result, lunar lava tubes could grow to sizes far larger than those on Earth. They can span hundreds of meters in width, large enough to fit an entire village inside. Despite their massive size, they remain remarkably sturdy and stable. Stress modeling shows that, thanks to the moon's low gravity, a lava tube with a roof just 2 meters thick can remain stable over a tunnel 1 kilometer wide. With a thicker roof, these tubes could expand up to 5 kilometers wide, creating an ideal space to establish habitats within. Imagine living inside a massive cave, a cave large enough to house an entire city. How fascinating would that be? How can we access these mysterious caves? The answer lies in the deep pits and skylights scattered across the moon's surface. Over millions of years, geological shifts, relentless moonquakes, and constant impacts have reshaped the lunar landscape. Shallow lava tubes have partially collapsed, giving rise to skylights. These skylights act as gateways to vast lava tube caves, a hidden underground world preserved for billions of years. Inside these caves, we encounter a world that is entirely different. Clean, with stable temperatures, robust structures, and most importantly, protection from the dangerous cosmic radiation above. But how do we know that these mysterious pits lead to massive underground caves? It all starts with cutting-edge technology. Since 2010, NASA's Lunar Reconnaissance Orbiter has used its high-resolution narrow-angle camera to identify sprawling lava tubes, some stretching up to 900 meters wide. These aren't just small cracks. They're potentially colossal voids beneath the lunar surface. India's Chandrayaan-1 mission took this even further in 2011. Using advanced imaging tools like the terrain mapping camera and hyperspectral imager, scientists generated precise topographic maps of the areas surrounding these skylights. The results? Detailed images showing branching tunnels at the base of pits in regions like Mare Tranquillitatis and Marius Hills. But mapping isn't enough. We needed proof that these tunnels were hollow. Japan's Selene orbiter delivered just that, detecting distinct echo patterns at the Marius Hills skylight. These patterns were unmistakable, indicating a vast underground cavity. To confirm this, NASA's GRAIL mission mapped the Moon's gravitational field, revealing regions of lower mass that lined up perfectly with these tunnels. These discoveries paint a clear picture. The Moon is home to massive hollow networks, just waiting to be explored. And this isn't just about scientific curiosity. It's the foundation for something truly groundbreaking. It's no wonder nations like China are eyeing these sites for their next manned lunar missions. Exploring these caves is about more than just finding shelter. These structures, formed by ancient magma flows, have preserved nearly pristine geological features beneath the Moon's harsh surface. Here, time has stood still, safeguarding samples, untouched by the weathering effects of space. Scientists believe these lava tubes could reveal the Moon's geological evolution, offering insights into the origins of the solar system itself. But that's not all. Within these caves, stable temperatures could allow for the presence of volatile compounds, or even frozen water. Water, an invaluable resource in space, is not only key to sustaining life, but also a potential fuel source. By splitting water into oxygen and hydrogen, we can produce breathable air and rocket fuel. This reduces dependence on Earth's supplies. These lava tubes also hold the potential to provide local construction materials. Lunar soil and rock could be used to build sustainable bases, turning the dream of a home on the Moon into reality. However, the path to conquest won't be easy. First, we must explore the environment outside these caves. This requires measuring slope gradients, gravel distribution, and the geomorphology of surrounding areas. The shape, size, and orientation of lava tube entrances also need careful study. Additionally, determining the thickness and structure of the overlying rock layers will be critical to ensuring safety for future missions. But the true turning point lies in exploring the interiors. Scientists need to know the exact length, width, height, and curvature of the lava tubes. They must assess the stability of cave roofs and floors, and their resilience against extreme temperatures and cosmic radiation. Such data will not only aid in constructing safe bases, but also pave the way for significant scientific discoveries. To achieve this, technology must take the lead. NASA is developing the Dune Axle, a rover capable of splitting into two parts. One part anchors itself securely on the surface, while the other descends into deep pits to map and capture images using laser scanners. Meanwhile, researchers at the University of Würzburg have built Daedalus, a small spherical robot capable of rolling through narrow corridors. Equipped with LiDAR technology, it can create detailed three-dimensional maps, providing a comprehensive view of internal structures. ETH Zurich in Switzerland has taken a bold approach with the Space Hopper. Instead of wheels or legs, this robot hops across rugged terrains, leveraging the Moon's low gravity. It's an ideal machine for exploring areas conventional technology cannot reach. Not to be outdone, China is also racing to explore lava tubes. Their mobile robots, paired with advanced 3D navigation systems, are mapping and analyzing these vast underground spaces. Preliminary calculations suggest that the roof of a lava tube, 3.5 meters thick, can withstand loads up to 275,000 kilograms per square meter. equivalent to thousands of tons. Some caves have roof thicknesses of tens of meters. More than enough to shield humans from cosmic radiation and extreme temperatures. What do you think if China achieves this? A massive lunar base with residential areas, research laboratories, and even manufacturing facilities, all safely shielded from the deadly hazards of the moon's surface. But it doesn't stop there. Imagine transforming lava tubes into habitable spaces. Picture yourself freely roaming inside these giant caverns, breathing Earth-like air and moving around by flying. The idea? To seal off these underground spaces and fill them with a breathable atmosphere, using basalt roofs 30 to 50 feet thick as natural protection against radiation and micrometeorites. This approach would create Earth-like conditions. Doing so would significantly reduce the weight, complexity, and shielding needed for surface habitats, offering a far more efficient way to establish permanent bases on the moon. But it's not just about living spaces. These lava tubes also hold the potential to become the farms of the future. During China's Chang'e 4 mission, scientists demonstrated that seeds could germinate on the moon. However, the harsh surface environment, with its sudden temperature swings from extreme heat to freezing cold, makes traditional farming nearly impossible. Inside the stable conditions of lava tubes, everything changes. Here, humans could deploy advanced hydroponic systems to grow food, providing astronauts with a steady supply of nutrition. A giant leap towards self-sufficiency. If such a self-sustaining colony can be built, humanity could live on the moon for generations to come. China is gaining a significant edge in the space race, fueled by immense state-backed resources. This is not just a competition spanning a few decades. It is a carefully planned long-term game. While private companies like SpaceX grapple with financial challenges, China is leveraging the full power of a nation to unlock the doors to the future. Their Chang'e missions are not merely a testament to technological advancement, but a bold statement of their ambition to establish a sustainable lunar base. For China, this is not just about conquering space. It is about reshaping the geopolitical order, where the moon serves as a springboard for further exploration, potentially to Mars. Elon Musk's vision of colonizing Mars ignites dreams worldwide. But can a private company withstand the immense financial pressures? The answer remains a daunting challenge. In contrast, China is pursuing a different path, a long-term strategy where failures are merely minor setbacks in a much larger plan. If they succeed in turning the moon into a colony, the conquest of Mars will no longer be a distant dream. We are witnessing the relentless evolution of humanity in space. What is unfolding is not just about technology. It is history repeating itself. Thousands of years ago, our ancestors left caves to explore a larger world. Now, new caves on distant planets await our arrival. The question is no longer whether we can do it, but when we will cross the threshold of the cosmos to begin a new chapter in humanity's story.